Hello class, we're going to take a look at the next section, which happens to be 9.2. Now, this is the main objective in 9.2. So what we technically have here is that we're going to be estimating or trying to estimate a population mean given an actual sample. And these are the basic requirements. Now, we're going to assume that the data is bell shape. We're also going to assume that it's a sample that is large, greater than 30, or bell shape, and then also that they're random samples. Now, these are the main conditions that we're actually taking into account. If you have the value of sigma given, these are going to be your critical values. They're going to be standard. And we typically look at 90, 95, and 99. This is a level of confidence. So if you're evaluating a 90% confidence level, that means that we're carrying about a 10% error, a 95 about a 5% error, and a 99 about an actual 1% error. Now, the critical values that we found in the last videos, those deal with the actual error that's associated with each of these evaluations. And we're basically looking at the following idea. If you're estimating the mean and sigma is not given, then all your values are going to be t-values. Now, the main formula is going to be as follows. If the standard deviation of the population is given, then this is the formula that we're going to be using to estimate the parameter of the mean. If it's not given, then there's a minor adjustment. You don't have the value of sigma, but you have the standard deviation of the sample. And then you don't have a critical value z, you're going to have a critical value t. And in any case, you're ending up with one of these two intervals. And the idea is that with any of those two intervals, you technically have an estimate with a little bit of error for the actual sample mean. Another formula that's going to show up in this section is if you're trying to estimate the actual total number of values, this is what n represents, to construct the given confidence interval, then in this case, you end up using this formula. Now, this formula reads n is greater than this value. So once you have a numerical value, you typically are going to round up and then technically write it as a statement as we need this many or more in order to achieve a certain level of actual confidence. If you don't have the standard deviation of the population, then you're going to be using the value of s. And for this estimates, the error will be most likely given. Now, let's take a look at an example. And in this particular example, they want us to construct a 95% confidence interval. So in this case, this is going to be c is equal to 0.95. And we're estimating mu. They're breaking distances, and you're looking at, well, the sample size, in this case, n is equal to 32. The sample mean is equal to 137. And the most important part here is that we're given the value of sigma. Because you're given the value of sigma, then in that case, this is the proper formula that we're going to be using. We're technically looking at this formula since we have the standard deviation of the population. Now, they want us to find a couple of values with this problem. And among the values, we're looking at, they want us to find the critical value and the actual standard error. Now, for the critical value, so the critical value, I'm just going to label it as CV. Since C is equal to 95, in this case, that's this statement here, you're looking at the following. Since sigma is given, in this case, we're looking at this scenario. At 95.1, it's going to be 1.96. So those will be standard. So in this case, CV is equal to 1.96. Now, that's actually going to be one of our answers. The next portion that they're asking is for the standard error. Now, your standard error is here. So this is what we're going to be looking at, the standard error. So in this case, I'm just going to write it as E. So the value of E, it's equal to the following. You're going to have the critical value times the following calculation. and we're looking at, well, the values of sigma over the square root of n. And this is equal to the following. So we're going to be evaluating 1.96 times the values of sigma happens to be 7 over the square root of 32. So please evaluate this and see if we're matching. I'm looking at 1.96 times 7 divided by the square root of 32. Please evaluate and see if you're matching to 2.42. And then it's going to be a 54. I'm rounding to 4 decimal places. So it's 2.42 and 54. Now, that's actually the value of the standard error, or in this case, I'm simply labeling it as E. Now, the main answer that they're asking us to do is to find the confidence interval. Now, your confidence interval is going to be given by this formula. So let me just write it as the CI. And in this case, we're looking at a 95% CI. It's going to be evaluated as mu. It's less than the following two values: the sample mean plus the standard error, and the sample mean minus the standard error. And then we're going to be actually bounding mu by the following two values. The sample mean is 137 plus, well, 2.4254, and then 137 minus 2.42 54. So mu, it's in between the following two. Please take a second and evaluate. And I'm getting that my upper bound is 139.425. And the lower bound is 134.575. Now, all of your actual answers that you're doing for the confidence interval are supposed to include the error or the level of confidence. At the very minimum, you're basically providing a statement that indicates that what you're evaluating is a simple confidence interval, not an actual value for the mean. So you would say something along the lines like the confidence interval for mu is, and then I'm just going to rewrite it as 134.575 to 139.425. And in this case, we're talking about feet. When the value of C is equal to 0.95. So all of your answers are supposed to provide some sort of an indication. In this case, the indication is that there's a little bit of error, and the error, it's basically about a 5%. So that's actually indicated here. Okay, now for this particular problem, they actually wanted everything, the standard error, the critical value, and so on. Take a second and see if you're matching to what I have. Okay, let's go to the next example. Now, in the next example, all they want you to do is to construct the confidence interval. And notice that they're not mentioning anything about the actual standard error or the or the critical value. So in this particular problem, we can go directly to the answer. I'm going to show you the shortcut. Now, on any confidence interval that you're just providing the shortcut, you're still required to provide the formula and technically what type of interval you're actually doing. So in this case, well, the 90% CI, it's going to be given by the following formula. So in this case, mu, it's bounded between the following two: x bar plus the value of the e, and x bar minus the error, where e is equal to the following. Now, you have the values of sigma. In this case, we happen to have the values of sigma. So therefore, our formula, it's going to be, again, this particular one, with this being our standard error. So you have to provide that. So meaning the formula, let me fix this. And in this case, it's going to be C of alpha times the values of sigma over the square root of n. And let me show you the shortcut if you're going to evaluate these with the calculator. So you're going to be basically running a C interval, and then you're going to type in the following values into the calculator. So let me pull out the calculator and let me clear everything that we have. So in this case, you're going to go to stats, then you're going to go all the way to test. Now you have the value of sigma. So in this case, this is going to be a C interval. So number 7. And in number 7, you have to input the following information. So the standard deviation happens to be 330. The mean, it's 1522. N is 110. And then the level that they're talking about, it's a 90%. Run it. And that's going to be your answer. So the only thing you have to mention is a sentence that includes the final value, and you are providing the formula. So in this case, you would say something along the lines that the 90% CI for mu is given as follows. And in this case, you end up having 1470 0.2, and then the upper bound, it's 1573.8. So 1573.8. And since your SATs, we're just going to talk about points. So that's going to be our final answer. Obviously, if you're doing this, I want to see the code. So you're writing out basically that this is a C interval, and all of this will go here. All the values that you inputted. For any problem that you're just doing the shortcut, you're still required to provide the formula, what is the standard error, and you only provide the critical value if they're actually asking. Once again, if they would be asking for the critical value, because see it's 90 for this particular one, your critical value would have been on the 90 level, it would have been 1.645. So they're not asking for it, but if they did, it would be 1.645. So let me write it on the side. So CV is equal to 1.645. Only if they were to ask. But on some of the problems, you may just go directly to the shortcut on the calculator. And what the calculator is going to do is will basically automatically evaluate the standard error.